All right, let's look at another example of a parametric equation on how to graph it and convert it to the rectangular coordinate equation. All right, so I have my parametric equations here. My parameter is t. I have x equals 5 cosine t and y equals 7 sine t, and t is between 0 and pi over 2. So I want to go ahead and graph this. So what I'm going to do is I'm going to create a table t, my x, my y, and then my xy. So you don't really need this column if you have an x and a y, but it's kind of handy to have so I can just look at points. So my t, I'm going to go from 0. I'm going to pick the unit circle pi over 6, pi over 4, pi over 3, and pi over 2. So if I plug this in, cosine at 0 is just simply 1, so this becomes 5. At pi over 6, cosine square root of 3 over 2, so this is 5 square root of 3 over 2. This becomes 5 square root of 2 over 2. This becomes 5 over 2, and then this is 0. All right, that's all from the unit circle, just multiplying the unit circle x values by 5. All right, so let's look at my y values. Well, sine at 0 is 0, but sine at pi over 6 is 1/2, so this is 7/2 because I'm multiplying it by 7 now. This becomes 7 root 2 over 2. This becomes 7 root 3 over 2, and then this becomes 7. All right, so I can write my points. I don't feel like writing my points, but it's basically just 5, 0. There are my points. You can write this out. You don't really need to do that column because if you have this, you already have your points. And let's graph this. Well, let's see. This is 5. This is 7. It's going to graph something like that. It's actually an ellipse. This longer. If this is 5, this is 7. It is an ellipse going this way. It's an ellipse along the y-axis. So I already know that idea. So let's take a look and see how to convert this into the x, y, or the rectangular equation of an. All right, to convert this is a little bit of a trick because I know this is an ellipse. So what I'm going to do is I'm going to use the Pythagorean identity because I know an ellipse is going to equal 1, and I know that sine squared theta plus cosine squared theta equals 1. So that's how I'm going to get my 1 to my equation. I have a cosine squared, and I have a sine squared, and I have an x squared and a y squared. So what I'm going to do is I'm going to square both of these. I'm going to say that x squared equals, oh wait, before I do that, let's get this 5 over here. Let's just get cosine by itself and sine by itself. So I'm going to say x equals 5 cosine t. I'm going to divide by 5, and we get x over 5 equals cosine t. I'm going to do the same thing here. Y equals 7 sine t. I'm going to divide by 7. I get y over 7. Y over 7 equals sine t. I'm now going to square both sides of these, and I'm going to have x over 5 squared equals cosine squared t, and then I have y over 7 squared equals sine squared t. Well, hey, I have a cosine squared and a sine squared, but I know what they equal. I can just plug it in. So let's see. I can say x over 5 squared plus y over 7 squared equals 1. This is the Pythagorean identity. Now I can just clean this up, and I can say x squared over 25 plus y squared over 49 equals 1. And there is my ellipse with my major axis along the y-axis, or parallel to the y-axis. Pretty straightforward. But there is a trick. You're going to have to use a Pythagorean identity. If it's an ellipse, it's going to be sine squared plus cosine squared. If it's a hyperbola, the hyperbola ends up being, I think it's secant tangent squared plus 1 equals secant squared. I think is what ends up being. So fairly straightforward. Just need to recognize a little trick that you have to use Pythagorean identity to get it into the rectangular equation. Hi, I'm Mr. Buzzer, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.